Today, I'm going to tell you the truth about light. And some of you will know why exactly I'm using those words. And some of you may be wondering why I'm saying I'm going to tell you the truth about light. Because the puzzle we're going to play with today is the question, hey, what is this light thing? It's there all around us, right? But what story should we tell ourselves when we ask, what is this light thing? What should we ask? What should we tell ourselves? And the answer, depending on whom you asked, could be one of these three stories. The first story is called the ray story, which is that light is a ray. It's basically an arrow in the sky. And it went to school, learned geometry and all. It's a lot like us, and it follows some rules. That's the ray story. The second story is what we call the wave story. The wave story is that light's basically like if you drop a pebble in water, you see little ripples going. Light's like that. So which means the bulb is basically like that point where you dropped the pebble, and then waves come out of that. The third story you may believe is what we call the particle or the ball story. The ball story is that light is just made up of multiple tiny little balls of energy, right? And when you are switching on a torchlight, what you're doing is that you're basically turning on a machine gun, and billions of these tiny pellets of light are going in all directions. Now, which of these three stories do you believe? Now, you may believe any of these stories, but in science, we decide to believe a story based on how well it agrees with all the experiments we do. And you might think, oh great, then tell me which of these stories agrees with the experiment. And the problem there is that light has got us really confused for a super long time. And because light's a sneaky trickster, you know what it did? It looked very simple, like a ray. We could even predict what it's going to do by using simple things like pencil and scale and all that for a long time, until suddenly all we did was one experiment where we made the hole really small and passed light through it. And suddenly light changed its appearance overnight and started behaving like a wave. We were super confused. And then again, all we did was shoot light at a metal like any other day, and suddenly light behaved like a particle, like a ball. It went and kicked out an electron from that metal. We were confused again. And for a long time, we called this confusion the wave-particle duality of light, which basically meant we don't know what light is. Until in the 1950s, Tomonaga, Julian Schwinger, and Richard Philip Feynman came up with a theory, which is a story, called quantum electrodynamics. And there they showed that you only need one story, which is that light is a particle. And with that, you could explain every single experiment that we could see in the world, which meant that instead of having two stories in our head telling, hey, if you're doing that, think of light as a wave. If you're doing this, think of light as a particle. Instead of doing all of that, you could just think of light as a particle called a photon. And this word photon may be new to you, but if it is, you know that the word photo is pretty familiar. It usually comes with light, which means that the word photon is what we use to talk about these little bullets of light. Now, whenever I mention this in a classroom, students always ask me, hey, but why don't they tell us this ever? And I think the answer is they're worried, oh, I can't mention quantum electrodynamics and all. It'll confuse the kids. And my question is, since when is confusion a bad thing? Anything worthwhile that you want to learn will come after some amount of confusion. So as we learn more together, I'm going to deliberately confuse you many, many times by asking you questions and playing with you. Now, when they introduce light to us, they say it's a ray, right? I've always had a question. Is this ray a real thing? Is a light ray real? Can I pluck it off the air, take it with me, and then throw it at someone? Can I take it, break it, and give it to somebody and play some kind of lightsaber fight? Or can I maybe put it in my pencil box and take it home, pencil box or wherever it is that all you people put things in these days? And we know that's not true. So the ray of light is not real. How can you imagine it? You can imagine it like this. If there is a bulb, and from that bulb photons are leaving, these photons travel in straight lines, right? As long as you don't trouble them too much. Then what you can do is imagine these photons being dipped in some ink, and then you leave them. As they move, they will leave a trail, like a jet plane leaves it sometimes in the air, if you can see. That trail is what I think of as a ray of light. It's not real, it's imaginary. But we see light that way. We use it to help our imagination, right? That's what we use a ray of light for. It's not real. And typically, very rarely do we just shoot one photon into the air. Very rarely. We shoot a bunch of them. So when we shoot a bunch of photons into the air, then we see a bunch of rays, right? Typically going somewhat parallelly in that direction. And you see them. We call them a beam, B-E-A-M, of light. One is called a ray and a bunch of them is called a beam.